Welcome back to our chapter 3. So I've got the schedule, which is kind of the best way to follow along. We don't have strict due dates on anything, but we have 6 chapters to study, and then we'll take a midterm on those. We're now basically at the halfway point. So we've gotten 4 days down. And so we'll talk about percentages today. Monday, we will have a work day to go through things, and we'll keep on moving forward with this. Down. So today, and I've been following along in the grade book, seeing many of you making that progress. Again, when you hit the 70%, you'll see it bump up to the full points, 100% of the points, 15. So 10 points in Canvas becomes 15 points. You can work through it as further if you'd like. It gives you the opportunity to kind of pick and choose which ones you want to work on. But if you basically go through, you'll get everything you need. Now for this lesson, I just want to show you where everything is at. I will put the recording of today's lecture here, but there's actually already some pre-recorded things that I've done separately, what we're going to do today. So there's a worksheet that you can use or download, especially if you're using this. I've got printed copies for you today. So actually in a moment, you'll be able to put your devices away. We're going to go to paper and pencil for an experience. And there's two videos for it. We will work through these, and by working through it, you're going to develop a deeper understanding of fractions, where they come from, how they use it, which percentages are really just a type of a fraction. You're going to see that. And I'm going to teach you one way to kind of work through percentages that always works, rather than the 3 different ways that the textbook teaches you. And then you have to choose, you have to read the question, decide which one of those methods it is, and then decide which one to use. If you follow along with how I've done it, and again, this was a method that a student actually taught me, you'll be able to get through it, and you'll be able to connect it to those 3 different ways. You'll be able to connect it to ways you already use, maybe no, but we'll get you there. So first I need someone who would be willing to do some community service by passing these out to everyone. Make sure everyone has a packet. We're going to start with the front page, or pass around. Yeah, do it however you want. And if you could go ahead and close down your devices, because we want you to focus on this as we do it. So let me pull up, I've got my electronic version of it. Kind of cut off there, but we'll see how this all works. And this first part is going to help us understand so many things about our world and why, and measurement, going back to that. Okay, so what I'm going to share with you is the different ways that humans have come up with dividing things. Okay, so today's lesson is about having a part of something, a percent, right? So we're going to talk about that. But first we're going to decide, if we have only part of something, we must have at some point taken a whole thing and divided it up. And so I'm going to show you what I have found to be the 3 ways that humans have gone about dividing things. And I'm not sure why the screens are doing this to me, but well, hopefully nobody will get a seizure or something from the flashing. I'm kind of getting it, but okay. So if you want to follow along, let's see, I think they're almost, I made 28 copies, so there should be enough for everybody. Has everyone gotten a copy of the worksheet packet? Anyone need one? Okay, so we'll do this front page here. And if you can follow along, because when you're using your hand to do something, what's happening? Your brain's activating. Sometimes people say you only use 10% or 15% of your brain. That's only if you're thinking. If you're moving, you're using like 99.9% of your brain. Most of the brain is about controlling our body. So when you involve your body in your learning, you're using it all. And you're right, when you use your hand, there's a part of the brain that's doing the math that's right next there. But not only are you going to use your hand, you're going to use your eye-hand coordination. So you're getting your brain to work left and right side and back and forth. So what we're going to do here, let me get my line. And we are going to, you're welcome. We're starting off with this first box. Let's see, let me actually, and what we're going to do is we're going to call this column one thing. Okay, so this is one thing that has not been divided, so it's 1 out of 1, if we want to think of it as a fraction. And then we're going to cut it in half. And what you're going to see is this is, as you do it, and you don't have to necessarily look at mine, but you're going to see that humans are pretty good at dividing things in half. We kind of eyeball it. We come down here, and I'm going to cut all of these in half. Now, on the back side of the sheet, there's an answer keys that has it all nicely done, but that's all we're going to do, okay? So, and then we're going to now focus on this thing called a half. We cut, certainly this long one is now cut in half. So what do we have in the top? We have 1 piece out of 2 pieces. That's how we write 1/2. So we see how we did it. What do we have in the bottom? Well, if we count the first one and the second, we have 2 out of 2, which is another way to write 1. We actually have a one thing, but it's one thing that's been cut in half, right? We have, it's now 2 pieces of one thing, but it's still equivalent, right? So we're going to see these equivalencies. But our ancestors, all of our ancestors did this, is then they would take what they cut in half and they'd cut it in half. So we again eyeball it, and you'll see this one is pretty doable. Well, and if it's not, we'll pretend that those are the same size, right? Got a cake and you're cutting it in half or something to share with someone else. How do you do the cut in half thing? One person cuts it in half and the other person gets to choose which side they get, right? So that's kind of the fairness, because we don't always get it exact, but we get it close. And again, we cut the bottom half in half. And we're just seeing how things, cutting things in half. And we're going to see this is actually going to empower us pretty good. So we've got a quarter of something that's been cut into 4 pieces. And the top piece is 1 out of 4. The piece after that, if we had both of those, that's 2 out of 4, which is equivalent to 1/2. You see, it's the same size as the 1/2. And if I really have no idea what's going on with this, so hopefully it keeps working. Maybe I need to turn it off and turn it on. But and then we've got 3 out of 4 and 4 out of 4, right? And we see equivalent fractions. 2/4 is the same as 1/2. 4 out of 4 is the same as 1. So far, so good. Keep going with this, and since we can cut this piece in half, and if we cut 4 pieces in half, how many pieces will we have in total? 8 pieces. And so we've got 8s, right? So we do this thing, and again, I'll come back here, and I won't necessarily write all of these 1/8, 2/8, but what you start to see is fractions is just a way of counting, isn't it? It's how many pieces out of, we divide a whole thing into so many pieces, and then the numerator is how many pieces we have, 3/8, 4/8. Thing is in math, so oftentimes we say it has to be in reduced form, but sometimes, 4/8 is somehow different than 1/2, isn't it? 1/2 is 1 piece, so that's been cut in half. 4/8 is that same amount of stuff, but it's been cut into 4 pieces. You got 4 of the pieces, right? 5/8, and so forth, all the way down to 8/8. Again, we just want to kind of focus on this, and then we do it one more time. Again, it might get a little bit boring. We could keep doing this for a long time. In fact, this is the way the Egyptians did their fractions primarily is they just kept cutting things in half. And so they have 8ths, 16ths, 30 seconds. You cut that in half, you get 64ths. Cut that in half, you get 1/28. We just keep going with this. Okay, and so we've got 1/16. 2/16 is the same as 1/8. And again, you'll just see that all of these come along. And again, the key on the back has it all written out, so you can write down as many as you want. The key part is that when you are doing the division, when you're dividing these, your brain is recording this action. That fractions is about dividing things into smaller pieces. So now that we've got that done, no, I'm going to keep going. So our ancestors, all of our ancestors at some point, sometimes maybe a few hundred years ago, sometimes thousands of years ago, the other way they divided things, because this is fairly, as you're going to see, is relatively easy to do. Can't divide things into 7 pieces very easily, but I can cut things in half, and I can cut things in a third, barely by eyeball. And I think maybe, and again, I want you to have that experience as well. So over here, we've got the next set of boxes. We've got 1, and then we've got thirds. So that's a little more tricky. That's about a 4th. I think a third is going to be about here. I take that piece and I go about here. So again, but if I was a professional divider, I would be very good at dividing things in thirds. And there's ways that you can go about doing this. But that's about, we'll say that those are all 3 the same size pieces. What our ancestors did after that, though, they didn't keep dividing the thirds into thirds. What they did, and you're going to see the reason I know that they did is, and you know that they did, is you're going to see what the evidence of what occurred afterwards. Let's see. We do this first. Thirds. So there's 1/3, there's 2/3, and there's 3/3. And again, the thing that has not been divided is 1/1. So instead of continuing to divide in thirds, what happened next is we divide the thirds in half, because that's a lot easier to do. And if we take a third and divide it in half, we get how many pieces? 3 pieces, each divided in half. Give us 6 pieces, right? So now we have 1/6, 2/6, which is the same thing as 1/3. But it's equivalent to 1/3, but it's not exactly the same thing. 3/6, 4/6, 5/6, and 6/6. Again, part of this activity, you're just seeing, fractions are just about counting how many pieces we have. Okay, and we do it one more time, and then we're going to ask a few questions and a little bit of reflection. So we cut each of the 6 in half, and again, it's relatively, I don't know if it's easy to do, but it's something we're pretty good at, cutting things in half. So we have 1/12, 2/12, 3/12, and so forth, all the way down to 12/12. Okay. And if you watch the video, I actually do take the time and I put all those in there, and there's some benefit to that. But when I was doing this, I became convinced that this is the way societies developed their division of things. And this is, let me ask you this. And it was because I was doing it at home, and I went and opened up my refrigerator. I got a can of soda out, and I noticed how many ounces was that can of soda. Those little Coke bottles, anyone remember? It's a 12 ounce. They were dividing in thirds into So that's, notice this piece over here, something's been divided into twelfths, the 12 ounces. We've got that size of soda. If you're a little thirstier, you might have had a little larger one, maybe one of those beers or something, whatever. Uh, those little larger cans, and how many ounces are those? 16 ounce. I started looking through, there's bottles that were 16 ounce, maybe those big bottles of Coke or something, but there's things that were 16 ounce and 12 ounce, and it was all across the board. It didn't matter what company, right? What brand. You start looking at those things. You look at your jar of mayonnaise or whatever. It's maybe 16 ounce or 32 ounce. You look at your jug of milk. You have a half gallon, that's 64 ounce, I believe. If you have a full gallon of milk, it's 128 ounces, which is the 16 divided by half is 32, 64, 128. You could see that they keep going this. You start to see, wow, looks like this is sort of how things happened. If you look at how we measure with our system of measurement in America, at least, we use inches and feet and miles and yards. Have you ever looked at a ruler, 1 foot ruler, and what is the foot divided into? Inches. How many? 12. That's this division system over here. But what's always bothered me is when you look at the inches, are each inch divided into 12 pieces? They aren't. And I thought that was weird. Why would you divide the foot into 12, and then when you get to the inch, do you realize they divide it in half, in half, in half? They divide it into 16 pieces, a 16th of an inch. They're using the other method of just continually dividing in half. The foot came from first dividing it into thirds and then halves and then halves. The markings inside each inch were simply because it's so small, probably, they just divided in half and half and half and half. So we got 16ths of an inch. But that always bothered me because it didn't seem natural. Why would one be 12 and the other 16? Now, when I did this, I said, that's because there's been two ways of dividing things up. 3 yards, right? There's 3 feet in a yard. So you take an inch, or you take a foot and you divide it into 12, but why do you take a yard and divide it into 3 feet? Well, because that's one of the ways of measuring. Okay, so everything that's been divided has either, they start dividing in halves, or they start with thirds and then move to halves. Okay, so there's these are what I call natural fractions, because this is what we do as humans. The thing is in the math textbooks, we give you fractions like 1/7. Well, you're not going to see a 1/7 here. No, it's an unnatural fraction. So when you struggle with fractions, it's because we have you working with unnatural, demonic, no, I don't know, I won't go that far, but unnatural things, right? 1/9 isn't even on here, right? Because that would be a third, and a third. We didn't do that. We did a third, and then we go to halves. These are our natural fractions. If we stick to these, we would all love fractions, because you can see how they interact with each other, how they're, it's really nice. Finding common denominators, easy thing to do with natural fractions, but when we get all these unnatural fractions that we have you work with, it becomes difficult. Okay. With that being said, there's one other type of measurement that was a little bit more technical, and that predominantly comes from Asia, in India in particular. And that was over there, they took the one and they divided it first into fifths. Now, this is hard. It's harder. It's doable, but you kind of got to go, okay, I could come here. There's a fourth. A fifth is going to be a little bit smaller, so I'm going to try this. Let's see what I need. I need a line. I'm going to try dividing in a fifth. So if that's a fifth, see that much, about that much. Let's see how good of a job I do. Sometimes I'm okay with this. So 1, 2, 3. Here's another fifth. Not real good. These last ones are bigger than the top, but they're supposed to all be the same size. 1, 2, 3, 4, 5. So we got 1/5, 2/5, 3/5, 4/5, and 5/5. And remember, the one piece that has not been divided is 1/1, 1 out of 1. The thing is then after that 1 feat of dividing it into 5 pieces, which was difficult, after that, they would divide it in half. And again, this comes from, I think we did a little bit at the beginning, looking at the hand has 5 fingers, and then there's 10 with the 2 hands. So it's also a natural way of doing things, but a little bit more technical again. So we get 1/10, 2/10. And again, you see the equivalent fractions. 1/5 is the same thing as 2/10. They're equivalent in size. 3/10, 4/10, and so forth. And what they would do after this is the tenths would get divided into tenths again. And this is our metric system, the worldwide metric system. Things get bigger by 10. And these you'll also see if you go into your refrigerator, right? You'll see others that are based on a metric system. You'll have 500 milliliters. You'll have 250 milliliters. You'll have things that are powers of 10. Okay, so this is the other, but typically these are the two. I'm going to say there's 2 systems of measurement, and most cultures have decided to do one or the other, but rarely do they do both. Right? We use the first 2 in America because we got it from the British. The British brought their system over. The British stopped using that system. They went over to the metric system because they became part of Europe, and the world has decided to go with the second system, which is an Asian-based system and which works with our number system. The school math we do is based on base 10, so that's all over there. But there's a cultural favoritism once you start using the half and the third. There's something really nice about it, and you get used to it, and you don't want to let it go. When I was in high school, and this was 40 years ago, probably twice as many years as most of you have been alive, right? They told us in high school that by the time we got out, 1980 was when I graduated, that we would be fully using the metric system, that we would no longer use inches and feet and everything else we came up with. It never happened because there was too much pushback. People were in love with their feet and miles, and they didn't want to give it up. So we didn't. Okay. But what I want you to see is that there's natural fractions, and then there's a bunch of other fractions which, are maybe not so natural, are harder to work with. We're going to see, again, this lesson is taking us into something called percentages, and we'll see percentages, percent is based on this system. And they take it one more step down, and we'll divide things into 100 pieces. We won't try that because that's be hard to do all these lines, but we could visualize that happening. Take the 10 pieces into 10 pieces, and we get something called a percent. And again, the Romans actually, they had a mix of systems. They were a huge empire, but if their army there was a centurion that was the leader of 100 people. So they divided things like that. They also used the other system, so they did mix it because, again, whenever you become a worldwide empire, you have to use more than one thing, and that's what the U.S. does. We're all over the world as well. So we'll see a mix of systems. The first system really came from Babylon, that empire. The other systems primarily focused from the Asian continent, India specifically, dividing things into 10. Okay, questions but your homework is go open your fridge and just start looking at the bottles, and you'll start seeing these connections. Oh, that's a 6-ounce soda. Oh, that's because of it's been something divided. Those little guys, and they got the 12-ounce, and that's just weird. I go, wow, this is. But I guess occasionally you'll see a strange one. Someone will have a 7-ounce something, a power drink or something. I've seen a few of those, but mostly you'll see these. Okay, so now let's go. I'm gonna have to flip this for you. Not that way. Here we go. Um, we're going to put this all together and talk about. We're going to get into percentages, and we're going to get a way of doing it. But what I want to do is I want to connect what we just did with how fractions work in general. And again, we'll stick with fairly one of these two systems as we go through this. And again, if you just follow along, and if you want to just sort of do the sketching along, remember, as whatever you do with this, we're not going to grade this. It's not a test or anything. You don't have to complete it, but it's there because it will activate your thinking. So here we are. Okay, so concepts and strategies. We're going to look at division, multiplication, addition, and subtraction. So what is a fraction? It's the number of pieces divided by how many we divided the whole into. So 4/5 is telling us that we're going to divide this piece into 5 equal pieces, and then we're going to take or have 4 of them. So again, that was one of the systems. We kind of eyeball it. It looks like about 1/5, and then I got to make about an equal, and then another equal. That's 1, 2, 3, and then that. And they're not perfect, but there's 5 pieces there. And again, if I did it right, they would all be the same size, right? Everything be 1/5. So I've got a 1/5 here, and then I get 2/5, and then 3/5, and then I've got my 4/5. And so this piece here is what we call 4/5. It's not a whole piece, it's 4/5 of a piece. I got an extra little piece to give to somebody else or something, right? So that's what a fraction tells us, is dividing things. And the reason Egypt used this system, you'll see it's within, if you ever study about Egyptian fractions, they did a lot of this because Egypt was on the banks of the Nile River Delta, which flooded, is at the top of Africa, right? It would flood regularly, and so that means they had a lot of food. You look around Egypt, around the capital there of Egypt, what do you see? Anybody, have you ever looked around? What's that? You seen pictures of the pyramids? Is there much greenery around those pyramids? There's a lot of sand. There's a lot of desert. And when you have sand and desert, you get not much food growing. And when it gets too dry, you get famines. So the people around them would have famines, and they come to Egypt, to the king of Egypt, who had his stores of food. They would sell themselves into slavery to get food. And Egypt would give them food. That's the whole story of the Israelites and the Egyptians. But they did that with a lot of people. Okay, we'll give you some food. You just come and, you build some of these big buildings for us. You build some of these pyramids. You become our slaves. We'll give you food. And if you don't have any food, you go do that, because otherwise you're going to die. But that's the basis of this division. Okay, dividing up food stores. And you'll see any culture that had sort of a surplus of food and was in that position to sort of dole things out have a very good mathematics of dividing things. Egyptians were very good at that. So let's come down here. We just try this. How would we represent 3/4? Well, we divide things in fourths. And again, we're back to maybe an easier system. We divide the thing in half, and then we divide each half in half, and that's how we get fourths. And again, a little easier than trying to divide things into fifths. A lot easier, actually. 1/4, 2/4, 3/4. Okay, so 3/4 is 3 pieces out of something that was divided into 4 pieces. Now, is 3/4 always less than 4/5? We look down here. This is what 3/4 looks like. This is what 4/5 looks like. It looks like it's more, but will it always be more? Why not? It all based on what we're calling 1. So if I said this was 1, 4/5 of this is not going to be nearly, so just think about it. If you got a big pizza versus a personal pan pizza, you get a slice of a personal pan pizza, that's not much. That's like a bite. You get a slice of the large, okay, that could be lunch. So the fractions themselves, you can't compare from one to the other, but it could compare it with one thing. Okay, let's think a little bit larger, because we've been dealing with some of this. What does 5/4 mean? The 4 means what? 4 divisions. The 5 means we've got 5 of them. So we've got 1/4, 2/4, 3/4, 4/4. Oh no, we don't have enough. What do we have to do? We got to go manufacture another fourths from someplace. So 5/4 is more than 1. It's got 4/4 plus 1 more. Okay. They oftentimes refer to that as an improper fraction, but I think there's nothing improper about it. So they want us to write it as a mixed number, which I don't like mixed numbers, but okay, it's 1 whole plus 1/4. The problem when we write that is that a lot of times in algebra, when we write two things next to each other, we imply multiplication. But when we're doing this, we're actually saying 1 plus 1/4. So mixed numbers are really saying 1 plus 1/4. And again, it's a way of writing it, but 5/4 is perfectly fine to write it. So if the top is bigger than the bottom, we got more than what we started with. We got more than one piece. Make sense? And again, just kind of go up. So now we're going to get into the fraction, the percentage. And this is going to be, as we go through this is going to help you with the homework. It's going to help you with the quizzes, as we're going to see. And this is where we're going to take, let me make this larger. We're going to take two fractions, and we're going to notice something about them. If two fractions are equivalent, and again, we got a lot of equivalent fractions in there, but if we had 4/5 is equal to 12/15, if that's true, what we're going to find is if we cross multiply, so we take 4 times 15, we're going to find that that will be equal to the other cross multiplication of 5 times 12. It always works if they're actually equal. If they're not equal, it won't work, but if they're equal, it will. 4 times 15 is 60. 5 times 12 is 60. Okay. And so that works with every two fractions that are equal to each other, proportion. And that's what we're going to work with. So here it is with sort of a missing piece. We have an x. We don't know what that is. We do, but we'll pretend we don't. So we can cross multiply 4x, 5 times 12. So 4x equals 60. And then we've just finished the solving equations, right, from chapter 2. Hopefully, or at least we went over it. So how do we finish solving for what x is? We divide by 4. Good. And 60 divided by 4, as we saw up here, is 15. And we saw up here, 12/15 is equal to, so x has to be 15. Okay, so it works if we don't know what one of the pieces are, but we know the fractions, the proportions are equal, we can figure it out this way. What I'm going to do is do a little bit of a shortcut, and I get this from the Indian math from India. They would do things like this, just a little sutra. So we're just going to call this cross multiply and divide. So instead of taking all these algebra steps, what we're going to do is we're going to cut this down to really a one-step process with two pieces. We are going to multiply the diagonal numbers. So 5 and 12 are diagonal from each other. That's the cross multiply. So we're going to take 12 times 5 in the order we want, and then we're going to divide by the other number that is across from the variable. I call it the odd one out. So we're going to do 12 times 5 divided by 4. Sort of it's one-step process. Notice we didn't get any algebra step in there. That's what our unknown is going to be. Cross multiply and then divide by the odd one out, the one that's not a diagonal. And we see we get 60 divided by 4, and which is 15. So we get that same answer, but if you'll take sort of this approach, notice you basically get one step and you'll always get it right. And it doesn't matter where that x is. Watch, we'll try this one. 6/11 we're being told is equal to 11 over 33. Cross multiply and divide. So I'm going to take 6 times 33 divided by 11. And that's going to be what x is. Now, I write it out like this. do I need to take 6 times 33 and then divide by 11? Or could I divide by the 11 first? I could divide by the, because they're similar operations. I could actually, oh, I can see 33 and 11 goes into 33. So if I take 33 divided by 11, I'm going to get 3. 3 times 6, 18. So that would allow me to do it in my head. If you take a calculator, take 6 times 33 and divide by 11, you'll get the same answer. So you choose which one you want to do. If it's just easier, I'm just have my calculator, I'm just going to multiply and divide. I'm not going to try to look at facts. That's okay. But if you want to, let me try this. I'm going to turn this off and turn it back on. Is it bothering anyone else? No, it's bothering me. I don't. It's maybe I'm just. It takes about 30 seconds. It'll restart, and then I think hopefully this will keep going. The recording will still show what we're doing. Okay, so and the thing is, we're going to set up every percent problem is a proportion problem. So we're going to teach you. I worked with another colleague of mine. He worked in the tutoring center here, and we looked at. Do you all know what the GED program is? It's an high school equivalency. So if you're an adult who didn't finish high school, I had some of my uncles hadn't. They went back and you study and you take a test, and then you get an equivalency for a high school diploma. We looked at the math curriculum for that test, and we said, if we teach you about proportions, like what we're doing here, that's where this activity came from, we will teach you about 70% of what you need to know, and we can do it like in one setting and a little bit of practice. And one day we could do what they were teaching the people over 4 or 5 weeks, and we would see success, and it would be almost enough to just pass that test with just this, the way we're doing this lesson. People that were teaching those classes decided, no, we already got our textbook, and maybe they didn't want their students to learn in one day what took them 4 weeks to teach them, because then that means the teacher's not going to get much money. I don't know, but they turned us down. But you guys got the benefit. So let's see if this thing will work again. I'm going to return them on. It's probably my fault because I paused them, and then after I paused them, they started having this problem. I think restarting will do it. Okay, so if you want, actually, I need it to work because now we're going to get directly into the percentages. So I want that on the screen. Okay, so we'll get that going. There, better. Okay, so percent, right? Per means to divide. What does cent mean? Got $1. How many pennies does it take to make $1? 100 cents. We call it 100 cents, right? And that's exactly what it is. A cent is 100. We're dividing things into 100 pieces. That's what a percent is. Okay, a way of measuring. What we'll find is there's always this proportion. When we're doing percentages, the percent over 100, however many, like 50% over 100, is equivalent to the number of pieces that we have divided by the whole part. Okay, so the pieces divided by the whole. Another way to call this, and we're going to see this, is the words is. This is what a student taught me. I never learned it this way, and they said it and it never made any sense. Is over of equals percent over 100. And we're going to see how this is. I already see this. What's he talking about? You're going to see this is going to get us to set up every percent problem almost magically. So watch this. This is and these are types of things that are in the homework here. So we want to set up the proportion. We're going to then cross multiply and divide, and we'll have our answer. what you're going to see is there's always the 100 because the percentages always have 100. So there's three other numbers. The question will always give us two of those numbers, and our goal is just to find that third number. So the question is, what is 37% of 28? So you see the word is and of. Is part of the question. We don't know what it is, right? So we have is over of. We don't know what the is. I'll just put that there. We know the of is 28. That's equal to 37% over 100. Remember, you will always have 100. And again, if you're good with percentages and this seems strange to you, maybe try it, but that's fine. If you've got something that works, I'm not trying to convert you to something that's harder. I want to make it easier for you. But what I find is if you've struggled with percentages, this one lesson will make it real clear. And again, it's because I myself had a struggle because there's three different ways, and I wouldn't always choose the right method for the right question because it scrambled on me. But a student showed me this, and after they showed me this, I got it right all the time. Okay, and so what are we going to do? We are going to, cross multiply and then divide. Okay, so we're going to take 28 times 37, and we're going to divide it by 100. We're going to get our answer. We're going to know what the is part is. We're going to be able to answer this. I'll let you guys do the work. Leave my calculator alone. What do we get? 10.36. Okay, and what you would have seen is you would have got 1,036 in the top, and then whenever you divide by 100, you just move the decimal over two places. So you can, you don't always have to use the I would use my calculator for the top for sure, and I would have got the 1,036. But then I wouldn't have to divide by 100. Oh, 100, just move it over two places. That's going to be 10.36. Okay, when you multiply by 100, you just move the decimals the other way. So you're going to see that but you'll pick all this up as you're doing things and spotting these patterns. That's the key part, is you'll have one method that makes it really straightforward. Did that make sense? And is that about right? Yeah, 10.36 over 28 is equivalent to about 37 over 100. Now watch, this is a different question. What percentage of 71 is 36? Is over of. Which part is the is? (71) is the of. The is 36. Now, it's not always the smallest ones on top. We're going to see, because we know we could be over 100% sometimes. So we can't just always depend that it's always going to be a smaller number. But if it's less than 100, it's, 71 is the whole, 36 is the part. And what would we have? We've got percent over 100. The percent now is what we're looking for. And again, this would be a different, the textbook would take a whole nother 1 or 2 pages to teach you a method to do this one separate from the other one. And that's where I'd get them mixed up. And if you try to use the wrong one for the other, you mess it up. But we're not. We're just going to cross multiply and divide, right? The two that are apart, are across from each other, 36.5. We're going to multiply that times 100, and then we're going to divide by 71. Now, there are other ways to do this, and you might do it in a different order, and it'll as long as you get the same answer. But again, this is just a way, if you've struggled at all with percentages, you'll do this a few times, and then you'll make your connections. Just like we did with the conversions. Some of you just noticed, sometimes I'm multiplying, sometimes I'm dividing. And some of you had a good intuition of figuring out when you multiply and when you divide. We had a method that helped set it up. But some of you, it was easier for you to just, I know I need to divide by this. Okay, so again, we do this, and again, move the decimal over two places. That's 3650 over 71. Now I bust out the calculator. What do we get? 51.4, and that's a percent, right? Because that's what we were solving for. So some of the questions, we want to know what percentage it is. Now, yes, you could have divided them and then multiplied by 100. Um, we can do it in different orders. And you might, again, you might already be good at this, and that's the way you do it. That's fine. Okay. Last one. So there's really only three things I can do, because remember, there's three numbers. They will always give us two, and we find the third one. So this is 15 is 18% of what number? So now this is, we don't know the of, right? We do know the is 15. The of we don't know. That's our variable, our x. We do know the percentage. That's 18. The percentage is always over 100. So that's the key part, is you always have that 100. And then what do? That cross multiply and divide. So the diagonals we multiply, the odd one out we divide. 15 times 100 divided by 18. How much? 83.33. And it seems about reasonable, 18 is a little bit bigger than 15. 83.3 is a little bit smaller than 100. That would make them about proportional. You can kind of get a feel for what these should be. Okay, but what you're going to see is that with this method, you don't have to worry about algebra. It's just kind of, you'll be able to just visually see, okay, those two numbers we multiply, divide by this, and it will work every single time by setting up a proportion. So far, so good? Okay, let's move into some word problems, and let's see how this one thing is going to help us solve all these word problems. And again, usually the hardest part is setting this up. If George's income is 2,300 and his rent is, now there's two is's here, so that might be a little, is 1,200, what percent, so there's the question, of income is his rent? So remember, we get a proportion. It's always equal to something over 100, and this something is the percent. From reading it, what percent? We don't know the percent, but we've got these two numbers. And it's hard to think of which one is the is and which is the of, but we could think of part over the whole. So which one of these numbers would represent a whole for George? Yeah, his income. That's all he's got. And then he's got to live off of that that's his whole money. That's his whole salary, right? The rent is part of what he spends. Okay, so the whole is 2,300, and the part is 1,200. And again, most of the time you'll be okay thinking it's the 1,200 was smaller, so that's going to be it. Most of the time you'll be right. Occasionally, though, remember, sometimes we're over 100% and we might be wrong, but a lot of times we're going to be right. Again, cross multiply, divide. And again, there's more than one way to do this, but if you just sort of, if you struggle at all, this will always get you the right answer. And what I find is, even if I could do it the other way, sometimes this method gets my mind thinking. Then I'm just in this pattern, and it's more fun. It's less stress on the brain. What do we get here? 52.17%, because that's what we were looking for. And yeah, it's about a little bit more than half. If you cut 2,300 in half, that's 1,150. This is a little bit more. So we got this feeling, yeah, it's a little bit bigger than 50%. Makes sense. I feel good. But the mechanics of calculating, set it up, cross multiply, divide. Okay. And here's just another. If George pays, I don't want to just keep jumping in, but we don't okay? Okay. If George pays 17% of his income, well, where's that going to go? That always goes with the 100, right? We already know 100. Here's our 17% of his income, 2,300 for food. How much does he pay for food? And again, we can kind of say, okay, income, yeah, that must be the whole part. Food is a part of what he pays. So that's the 2,300 down here. We don't know what the food budget is, but now we can cross multiply and then divide. So 2,300 times 17% over 100 gives us how much is he spending on food? How much? 390. Oh, geez, that's a lot of money. I don't know. Probably spending twice that now, right? Because with inflation, 391. So there we go. Does that make sense? How's this working with setup? Yeah. And we'll see Sally. Now she pays 19% of her income on food. So maybe she's buying better food. I don't know. Um, and but she only spends $200 on food. How much is her income? So we can see 19%. So 19 goes with 100. Now we've got an is over the of, or a part over the whole. 200, her income must be the whole. Her food budget should be smaller. Again, 200 over her income. And again, notice the unknown is in a different place, but we don't worry about it. We just cross multiply and then divide by the odd one out. So 200 times 100 divided by 19. I guess it's like 20,000 divided by 19 gives us about what? 1,052. Okay. Not making as much as George, but spending more of our money on food, that's okay. So far, so good. We're almost there. And then we're going to go in and we'll see, we can make a couple connections with this. So the other thing we do with percentages is we do we mark business, we buy things and then we want to sell it at a higher, so that's how we make a profit. We do a markup. Sometimes we're trying to sell something and nobody's wanting to buy it, so we have to mark it down to get people to buy it. We do a discount. So that's the two business use, one of the two main business uses of percentages, mark up and mark down. So what are we doing though? We're taking a whole thing, right? Like in our first activity, and we're marking it up or marking it down. We're dividing it into 100 pieces, right? And we're taking a percentage of that. So we always start with 100%. When we mark up, we're adding to that 100, and we're adding that piece. Like that was that 5/4, right? We had the whole piece, but we needed to get another one. We added more so markups will always be adding. So we'll have a number above 100%. Markdowns are the other thing, is what we start with as 100%. It's 1/1. And then we subtract. We're discounting the piece. We take some away. And so we always end up with less than 100%. Okay, so that's the key. If you're doing a markdown, you better end up with less than 100%. If you're doing a markup, you will have more than 100%. So it really is kind of what I always find is markup is seemed to be easier to do, because if the price is increased by 10%, we start with 100, we add how much? 10%. And what's 100 plus 10? 110. So you'll see the addition is very easy because you're just 100 plus whatever. 120, if we got a 20% markup, it's 120%. Now, remember on percentages, as we do this, I'm gonna make connection to this. Remember, we always had a percent divided by 100. So if I have 110% and I divide that by 100, what do I get? 1.10. So I can list this as a percentage, 110%, or I can also list it as 1.10. I'll do it that way, and that's a factor I can use to figure out what it is. And we're gonna see that's what we're going to be doing with this section. Okay, so we use this 1.10 to do calculations with a little bit easier, but we're taking it from our proportion, right? Because we know the percentage, we're dividing it by 100, and so we can directly multiply whatever's on the other side by the 110%. Okay, so we're going to see that a little bit. 120, I just want you to get in the habit, when you see 120, you can also see that that's 1.2. And just move that decimal over 2 places. But just kind of see those connections, because when we're doing the math part, we'll be using 1.2 in place of the 120%. Okay. 37% increase, again, just add 37. It's 137%, which is the same thing as 1.37. 63%, again, we're just adding 63% to the 100, 163%. So that's 1.63. So we bought a jacket for a price, want to do a 63% markup because we want to make some profit. We would use 1.63. Exactly. We're just moving that over. And where it comes from is from right up here, because we always take the percentage divided by 100, and that's how we get that decimal. So if you forget, just do that. I'm a math teacher, and my wife had, because she was taking a class, actually she's taking this class, and so she had to take it from a different professor. She goes, "Why do we always divide by, or why do we move it by 2 decimal places?" And I said, "I don't know. We just do it." Because I just been moving it. And after a couple of days ago, "Oh, because we're dividing by 100." She accepted that explanation. Divide by 100 made sense. Move it over twice just seemed like some tricky rule that somebody came up with. Okay. The other part is a little bit harder. If we're decreasing or marking down, we're going to subtract the percentage. Not necessarily. So what's 100 minus 10%? That's 90%. Or 0.90, right? Move the decimal over 2 places because dividing by 100. So this is where it gets if a decrease by 20%, we subtract 20%. Mark up, mark down. And again, have to do the subtraction. That's going to be an 80%, which we would use 0.80 for our multiplication. 37%, we would subtract 37%. That's 63%, which is 0.63. And finally, 63%, we subtract 63%, which leaves us with 37%. And so that leaves us 0.37. So it wasn't selling very well, so I discounted by 63%. Now they only paying 37% of the price. Okay, so we'll see if we'll be using this. So we could do these also. These will still work with the proportion if you want to use proportions on this, but we could also use the markup markdown approach. So this one, we'll kind of throw this in here. If the price of a jacket is $152, sales tax is 9%, what is the total amount paid? The total amount paid. So you're going to pay for the jacket, you're going to pay the sales tax. What is the mathematics that's happening here? Aren't we just adding? So we're taking 100% of the price. We're adding 9% for the sales tax. That's 109%, which is 1.09. If we multiply this by the price of the jacket, what we're going to get is we're going to get the total price. That 1 will give us the price of the jacket, the 0.09 will give us the tax, and it's already been added together. Somebody. What do we get? 165? 65.68. So that's what we would actually pay for the jacket with the taxes. Now again, we still could have used the proportions. I'm just going to show you this, 9%. But if we do this, we would probably want to say, since they want the total amount, I want 109 up here. The jacket is just part of the price. The total price includes the sales tax, so the part is 152. This is what I want to get, the total price. I could cross multiply and then divide. And I should get the same thing. I hope. I don't think I do. Oh, I won't. That's why I don't like to set. This is a little trickier. Let me back up. Actually, we'll do the 109 over 100. Okay. In this case, the 152, remember what was I using the 100% for? That was the price of the jacket. So this is where actually the 152 goes down here. The sales tax or the total price is going to be up here because it's got the 100 plus the 9%. Okay, so that's a little tricky one. So it's 152 times 109 divided by 100. And now we'll see, that's really what we did here. We get the same thing. Notice the top, though, is going to be bigger than the bottom because it's a total. We also could have found the sales tax separately and then added it. So there's another way to do it, however you want to. But you're going to see that this method that we used over here with kind of doing the markup approach will be one of the more, will be most helpful for us as we go further into this lesson. Okay, let's go ahead and do with the markup markdown thing. So then if a 147 pair of shoes is on sale for 25% off, what is the price paid for the shoes before sales tax? Okay, so 125% off, that's a markup or a markdown? Down. So again, we think of it, it's 100% minus the 25%. We're going to be using 75%, right? That's the amount we're going to pay, the 25% discount. 75% is 0.75. What do we do with this number? We multiply it times 147. Okay, so we just do the markdown, turn it to a decimal, and multiply. And we get that our $110, 0.25. See how we can directly calculate that. And it's less, it is a discount, so we went the right direction. And okay, so we just mark down and multiply. So far, so good. I think we're almost done. This is the last concept, and you'll see some of these. This is percent change. So we've got percent change takes time. We start with a value, and then we change to a new value. It could be in a markup or a markdown. We don't know. What we're actually trying to figure out is how much was it either marked down or marked up. What you're going to find, the way I do this is if you'll just remember, it's the new minus the old, so the new price minus the old price, and the percentage is always in relation to the old price. So just think of new minus the old divided by the old, multiply it by 100, and you'll turn it into a percent. Okay. A watch was purchased for 150 and later sold for 175. So the hardest part of this sometimes, which one is the new price, which one is the old price? How about the 150? Is that the new or the old? It's the old. So just think in terms of times, that's the original price. That's what we paid, right? So I label it the old. 175 is the new. So just follow through. It's going to be 175 minus 150 divided by 150. It's always relation to the old. To turn it to a percent, we multiply by 100. So that's the calculation we're going to do. 175 minus 150, that's 25 over 150. The 25 they will call the amount of change, right? it went down or went up by $25, but this will give us the percent of change. 25 divided by 150 times 100. What do we get? Anyone? Repeating, so maybe 16.7 if you want. Round it at some place. 16.66666, right? So it was a percent. It went up by 16.7%. Now, sort of another way to do this, a little bit easier, you could have taken 175 just divided by the old 150. What do we get? If you do that division, you're going to get 1.16666, or round it to there. Notice there's our 16.7%. Subtract off the 100%. So that you could use either one of these formulas. So if you want to use the new minus the old, this one will give you the percent change. If you just take the new divided by the old, then you're going to get a number that in the end you'll subtract off the 100%. Okay. Notice you're going to do this subtraction at some time. You either do it here or you do it at the end. And it's what I'd like to do is I give you options, and then you'll find one works more naturally for you than the other. And you might not even anticipate. You might say, oh, this looks harder. Oh, but in a way, it's sort of mentally easier because it makes more sense. So 2 ways. Choose which one you want. This one will always work. Sometimes I forget which is which, but if you just take the new price divided by the old price, you'll get it, and it includes 100%. A book was sold for $76 and later sold back to the store for $35. What was the percent decrease? Again, here, which one's the new one? Which one's the old one? Good. The 35 is the new. The 76 is the old. And you could kind of see this, right? 35 minus 76 is going to give us a negative value. 76, not 75, because it went down, and we always divide by the old. It's almost 50%, right? Maybe a little bit more than 50%. $53.94. About 54% on average. So that makes sense? $35 minus 76 divided by 76 times 100 will give you your percentage. And I think for us, we don't have to go into this is similar, so we're gonna, this was for another, this actually I did for the GRE test, because they ask questions like this, but our homework's not. It's really this percent change. Okay. So do you feel ready to take a look at the quiz? Let's do it. Get some work done here. We'll be moving on. Okay. Let's go back and let's see if we learned everything. That'll kind of, and sometimes you'll see that we've learned everything we need to know, but we want to kind of get in how the questions are asked. And so, yeah, if you want to get out your devices and stuff and pull it up, we can kind of work these together. So we're going to go through the homework quiz and work the 5 to 6 questions. Okay. A lot of words here. Okay. see if we can do this one. So a lender requires a minimum down payment of 20% of the value of the home. You have $26,000 cash available to use as a down payment toward a home. Determine the maximum home value that you can finance. Okay. So we've got a down payment and we've got a price for the house. What's the relationship between the price of the house and the down payment? Which one is the part? Which one is the whole? That would be the part, because yeah, that's part of the whole. Yeah, pay 100,000 for a house. I pay 16,000 for the down payment, or 20,000 for the down payment. Good. So we got the percent's always over 100. So 20 over 100 is going to be 26,000, which is the down payment. It's the part over the whole, which is the price of the house that we could. I'll just put P, price of the house that we could do. How do we do this? Again, we could just cross multiply and divide. So 26,000 times 100 divided by 20 will give us 5. Is that right? 130,000. 26,000 times 100 divided by 20. Yep. Cheat like just clicking that, but right. Questions on the setup? Yep. Right, right. You, yeah, so don't put any cents. But 130,000. Okay. So far, so good. All right. Notice how, again, just set up that proportion. We're going to see that works a lot with this. Absolute and relative change. So this one is the ones we just did. Politicians' support increases from 38% to 60%, new and old, right? Old and new. Determine the absolute and relative change. So what's the absolute change? It went from 38 to 60. 60 is the new, 38 is the old. So we always just take the new minus the old. We'll divide by the old. New minus the old is going to be 60 minus 38. We will divide that by 38. But we'll do the top part first. That gives us 22 divided by 38. The 22 is the absolute change. Okay, so that the absolute change is when we do the subtraction, we're just doing the new minus the old. The relative change is taking that number, the new minus the old, and dividing it by the old, and then multiplying by 100. Okay, so take 22 divided by 38, and then multiply it by 100. What do we get? 22 divided by 38. 0.5789. Multiply by 100, you're going to get 57. We'll round the 8 up, 57.9, because they want it to the nearest tenth of a percent, 57.9. Do a check, 22% and 57.9. The absolute change was 22 percentage points, but the relative change, a percentage he went up with, was actually 57.9. It's a pretty sizable change. Must have got popular. Good with that? Okay, moving on. A shirt was originally priced at $40. The store is having a 20% off sale. Is that markup or marked down? Marked down. Off is we're taking it away. How much will you pay for the shirt after the discount? Remember, we can just do this as a markdown. 100% minus the 20% means we're going to pay 80% of the price. Remember, that could be 80% is 0.80. And if we just multiply that by the original price, the $40, times 0.8, we will get the discounted price. And that should be about $32. 40 times 0.8. It wants us to round it to the nearest cent. There are no cents, so I guess we just 32.00. I'm not sure it matters. It might still count it right if you just put in 32, but if the nearest cent is, there are no cents. 32, yeah, even their answer doesn't have any decimals. So again, that was from the markup markdown section. And what's cool is I didn't even make that worksheet for this class. I made it to teach for a test preparation, again, because it helps just that technique. And what you're seeing is that same technique works for whenever we do anything with percentages. Okay, it's especially going to work here. Now this is also going to tie in a little bit from chapter 2. We ready for this one? A little bit more involved. Okay, let me make it a little bit, there we go. Still kind of read that. Of course, you can follow along with your computers. So what we've got, we're going to have two systems here. Okay. After graduating from college, Carlos receives two different job offers. Both pay starting salary of $60,000 per year. But one job promises a $3,000 per year raise, while the other gives a 4% raise. So one is going back to chapter 2, that's a linear equation. So remember from chapter 2, we had things like y equals mx plus b. B was our starting value. What is the starting salary? 60,000. Actually, I'm going to write that first. We're going to start getting paid 60,000 at the beginning. Each year, we're going to add how much to the salary? $3,000. Our salary is going to go up by $3,000 every year. That's sort of the promise. So what we're able to do is, and you could use the letter T. I like to use X. What we're going to see is that we could directly plug these numbers in and get these values here. So for this one, and again, if your numbers are different, you'll have slightly different numbers. The slope, the rate of change is 3,000 for this one. I put in 160 plus 3,000 times 1, 3,000 times 1 is still 3,000. That's going to be 63,000. To figure out what the salary would be after 5 years, remember that every year for 5 years it's going to be 3,000 added to it. I just use this formula, 60,000 plus 3,000 times 5 for 5 years. 3,000 times 5 is 15,000. 15,000 plus 60 should be making 75,000 at the end of 5 years. Do maybe one more. 60,000 plus 3,000 times 10. 3,000 times 10 is 30,000. So 30,000 plus 60,000 is 90,000. I'll just do a quick check. Does that one all make sense? And again, you could do the last two ones as well. This next one is directly what we were doing today. Our salary is getting a raise of 4%. So if we're getting a raise of 4%, is that a markup or a markdown? It's a markup. So we're getting our salary of 100% plus 4%. What we're going to want to do, 100% plus 4% equals 104%. We want to turn that to a decimal, move it over 2 places, 1.04. So what we're going to do is we're going to take our starting salary, 60,000, and we're going to multiply that times 1.04 for each year. And we're going to say, well, let's just do it this one time. So for 1 year, 60 times 1.04, what does that give us? 60,000 times 1.04, come up with 62,400. The next year, what do we get? We get this amount with a raise of 1.04. And each year, we just kind of keep multiplying by 1.04. So to figure out what the raise would be after 5 years, we would multiply 5 times. What's a shortcut way in mathematics to show repeated multiplication? Exponents. So this, instead of doing it like that, we could do it this way, just a lot of writing, or we could just say, hey, let's make it easy on ourselves. It's 60,000, 1.04, and this exponent up here will be however many years. It's an exponent thing. So if you're using a cell phone for your calculator, if you turn your calculator sideways, you all of a sudden have a scientific calculator that will let you do exponents. It is. It's the one that says x with the little y. That's an exponent key. So you would put in your 60,000. Well, actually, no, 60. Well, not 6. Clear that. 60,000 times 1.04, and then you hit that x to the y key. And for 5 years, we're going to put 5. So this is 5 years of change. And then hit enter. Yeah, you'll get a lot of decimals. We'll round it, what do they say, to the nearest dollar. So we'll drop off the exponent. So I get 72,999.17. I'm going to put in 72,999. Let's see if that worked. For mine, it worked. Again, you'll see for yours. So it's just learn how to do the exponents. If you have a handheld calculator, it might be a little easier. Let's see, I've got so calculator here. So yeah, scientific calculator. What I'm doing is I'm taking 60,000. Better to show it here, times 1.04. Before I do anything else, I do this x to the y, or the caret if you've got, yeah, there's a little chevron thing. I put in the exponent, and then I hit it equals, and it's multiplied that. Take 1.04 to the 5th power, multiplied it, and that's what it's going to give me that. So that is the same thing as multiplying by 1.045 times. Okay. I want to do it for 10 times. Again, I always take the starting value, the same starting value, 60,000, and I'm going to multiply that by 1.04, the markup, but I'm going to raise it. I'm going to do it for 10 times. So I do x to the y, and I hit 10, enter. I'm now at 88,815, so that gets rounded up. What's that? 88,815. So I would put that in, and that's what we get. What you see is that actually that linear equation initially is growing faster. After 10 years, we're getting 90,000 instead of 88. But even at 4%, what you're going to find is by the year 20, let's just go ahead and do the 20th year here, it's actually going to be bigger. Of course, maybe you want to retire after 10 years. So which job do you take? It just depends. So again, we could jump out to 20 years. We don't have to do the ones in the middle. 60,000, 1, 2, 3, times 1.04. And again, it's exponential growth. We just raise that to 20 years. And that gives us 131,467. And we could do the same thing up here. We could plug in 20. 20 times 3 is going to be 60,000 plus 60,000. That's going to be 120,000. So you see in the end, after 20 years, the percent change actually was bigger than the amount change. But for like 10 years, and you could check out 15. I think maybe 15 years, it might be about where they're about equal. Okay, so there's these two ways. What you're going to see is when we get into lesson 4, we're going to be comparing these two ways. So the work we're doing right now is going to pay off when we get to chapter 4, because chapter 4, there's really not going to be that much new to learn. It's just we're going to be comparing these, the linear and the exponential, the percent and the amount. So far, so good? Okay. And again, you could kind of finish those up, but you feel like you got it enough to work with? Any questions? Okay. So now, actually, this is going to be the easy part. Now that we understand this, what is this number in the front on an exponential equation? These numbers that are in the front of what we're multiplying by, those are the initial value, starting values. These numbers inside, the decimal ones, what are they? They kind of tell us how much it's changing, right? There's just whether it's a markup or a markdown. Okay, so if I have this first one, let's tell the story what's happening here. If these are the balance in 3 different savings account, what could you tell me about A? How much money was put into account A? $900. Is account A, is it growing or is it shrinking? Is it getting marked up or marked down? Is it more than 100%? Yeah. So one way to do this is it's a decimal. We could turn it back into a percent. That's 105%, right? That's the way I think of it. That's more than 100%. So it's increasing by how much? It's increasing by 5%. The 100 is we're getting all our money back. 5% is the additional interest we're getting. So we get our $900 back plus some interest. That's how it works. So yes, it's a markup. How about B? What did we start with in B? 1,100. And what is the percent? In this case, 1.038. That's 103.8%. So it's increasing by 3.8%. Which one's bigger? 3.8 or 5? 5. Okay, so how about this last one, C? We put in how much money? 5,000. We put in 5,000. Is it gaining? Is it getting marked up or is it getting marked down? We're losing money, aren't we? We're not getting our 100% back. It's only 85%. And so again, what we do is we do the 85% minus 100. Well, we're losing 15%. We better get our money out of that because it's going to be going down, isn't it? It's a 15% loss. Okay, so that's how, looking at those equations, we can tell what's happening. We can tell the percent change, whether it's getting marked up or getting marked down. It's all based on that 100. So we're, from both of them, we're subtracting 100%. Not really sure what I did to this thing today. It's not very happy with me. So now we can answer these questions because more than one may be right. So the balance of account C is decreasing at a rate of 85%. Is that true or false? Sort of true that it is decreasing, but it's not 85%. The decrease rate is 15. So that's not, so we don't mark that one. It's this part that's not right. Account A is growing faster than account B. You all said, yeah, 5% is bigger than 3.8. It's growing faster. Yeah, so we'll mark that one. The balance of account A is growing at a rate of 5% per year. Yes, it is. It's not 105% per year. That it's, the growth is only the 5%. Account C had the largest balance in 2012. Yeah, that was the one we deposited because the front number is the biggest. We weren't very good investors, were we? We put our most money in the account that's losing money. That's usually what I did. So, okay, put it in the wrong place. So those would be the correct answers. And again, for yours, it might be different. You have to compare. But that's how you're looking at it. It's just from those equations, you can tell what they started with, and then you can tell whether it's increasing or decreasing based on that, the number that the exponent's on. Is that making sense? Okay. Got one more and then we're good. And this is just kind of the last application. We've got an equation again, just like we had up there, an exponential. And this one represents the value in dollars of a car T years after it is purchased, and then we want to answer some questions. So one of the question is, well, let's just see if we can, what's happening to the value of this car? What was the value of the car at the beginning? There it is right there. It's $31,500. That's what we bought the car for. Okay. Is the car's value increasing or decreasing? That's this number here. It's decreasing. We're only getting 94% of the value back. So how much are we losing each year? Actually, do it the other way. We subtract off 100. We're losing 6% a year. Does that make sense? So that's, sometimes it's harder to see the decreases than the increases. But that's what that equation will tell us. So the value of the car is, click here, it is decreasing at a rate of 6%, well, 6, and then down here, and it's 6% per year. And we know it's per year because that's what the T is. Each year it's going to reduce by 6%. Okay, it's not just 6%, but it's 6% per year. And then the purchase price of the car, well, we already identified that's $31,500. And you can see there it is, and that's just in dollars. So you have to select all of those things. But notice those are getting us to look at an exponential equation and be able to tell the story of what's happening there. What was the starting value? That's the number sort of in front. The rate of change, whether it's increasing or decreasing, is the number that the exponent is sitting on. And if it's above 1, that's above 100%, it's increasing. If it's below 1, it's decreasing. And again, in both cases, we subtract off the 100% to figure out the percent change. And that's our lesson. Make sense? And again, part of this is as you go through, hold on to those notes. You find the way that works for you. Again, I know you've probably done percentages before. Probably back in 4th or 5th grade, you were doing some of this. Actually, we didn't even have to do that. We just took the number here. Yeah. So yeah, the purchase price of the car is the $31,500. So it's that. Yeah, that was the starting price. Now you're right. If they would have asked what's the value in 5 years, then we would have had to multiply and put the exponent on, and we could calculate that. But this one was easy. It was just yeah. 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 We go through. So anyway, we got 10 minutes left with class, but what's today? Today's Wednesday. Monday is a complete work day to go through this. If you get done early, that's great. If you're got things that you're still working on, that's fine. So come in and again, we will use all the time to help you with any questions you have. If you don't have the questions, find something else to do with your time. I'm sure you got other things going on in your life too. So thank you.